Now we are going to study question from July 2019 exam, question 3. Okay, everyone please give the heading. July 2019 exam, question 3. This is the question that we are going to study now. Okay, now guys, try to see the scenario here. What the question want to say? A projectile is fired. Okay, see whatever mean by projectile. See, a projectile means what? Whatever the things we are going to throw. Okay, that is meant by projectile. Okay, a projectile is fired vertically upward. See, how is the motion? See, there are two chapters. In mechanics, there are two chapters. One chapter is linear motion. That is we are currently studying. And another chapter is projectile motion. We will study after few days. There are two chapters. And in both the chapters, there is a word will come. There is a one word will come. What is the name of that word? Projectile. Okay. There is one word will come. That is the name of that word in both the chapter, projectile. Now you may think, out of these two chapters, which chapter? Question is of which chapter? Okay. Now see the scenario. How to identify the question from linear motion or projectile motion? See, here projectile is fired vertically. Whenever that is meant by fired vertically, means motion of the projectile is what? Vertical motion. Fired vertically means motion of the projectile is what? Vertical. Okay, you got the meaning of vertical, guys? So this is meant by vertical. Okay, so vertical motion, it may be upward or it may be a downward. Okay, so whenever we have a vertical motion of the projectile, it means it is in linear motion. Whenever we have a vertical motion of the projectile, okay, guys, are you getting my point? Okay, projectile means what? An object which is moving in the air. Okay, what is meant by projectile? Projectile means what? An object which is moving in the air. Now, how to identify that projectile is following linear motion or projectile motion? Whenever in the question they are saying an object or projectile moving vertically, means in this question, how we come to know that it is question from the linear motion? Here what they said, a projectile is fired vertically. Okay, so this question is belongs to which chapter here, guys? This question is belongs to which chapter? Linear motion. And how do we come to know that it is linear motion? Because here they are saying vertically. What they said? Vertically. So from that we come to know that. And what is meant by projectile? An object which is moving in the air. Okay, what is meant by projectile, guys? Which is an object which is moving in the air. Okay, guys, are you getting my point? Try to see the scenario here. So a projectile is fired vertically upward with an initial velocity of what, guys? 305 meter per second. So what is meant by initial velocity? We denote initial velocity by what? U. 305 meter per second. Try to see the point here. Very, very important discussion. Meter per second. The effect of air resistance, guys. The next word is very, very important. The effect of air resistance is constant. So here in this question, air resistance is not negligible. Guys, listen my question, listen my words here. Here air resistance of air is not negligible, because they mentioned in the question the effect of air resistance is constant force equal to 1/7 of the gravitational force. See the wording, The effect of air resistance is a constant force equal to the 1/7 of the gravitational force experienced by the projectile. Try to see the scenario here. So what does it mean, guys? So here air resistance is not negligible. Here, guys, in this question, air resistance. See, if they have not mentioned anything about air resistance, in that scenario, it is a negligible. But here, air resistance is negligible or not negligible? Not negligible. And how do we come to know that it is not negligible? Because in the question, they have mentioned clearly what they have mentioned, guys, in the question. See the scenario. The effect of air resistance is a constant force. So we have a constant force as air resistance equal to 1/7 of the gravitational force. So here in this question, air resistance is not negligible. And see the scenario. Air resistance is what, guys? Not negligible. Okay, is not negligible. And what will be that F resistance, guys? What is F resistance? What is F resistance? 1/7 of the gravitational force. What is meaning of 1/7, guys? What is meant by 1/7? 1/7 of gravitational force. See the wordings here, guys. 1/7 of the gravitational force. Okay, guys, are you getting my point? So here Fr means what? Our resistance force, air resistance force. Okay, equal to 1/7 of the gravitational force. Now, what is meant by gravitational force, guys? What is meant by gravitational force? We studied weight. Weight of the object means what? Gravitational force. So suppose object has a mass m. Okay, so the projectile, suppose we assume projectile has a mass m. Okay, we will assume m as a mass of the projectile. Then what will be the gravitational force on the projectile? So what will be the gravitational force on the projectile? Gravitational force on the projectile will be its weight. And what is the value of weight, guys? What will be the value of weight? Weight is means what? mg. Very good, guys. So that's why from the beginning I am explaining you. So can we write Fr is equal to 1/7 of the weight? Try to see the scenario. 1/7 of the weight. And next point is what, guys? 1/7 of the weight. And that will be equal to what, guys? 1 by. So Fr will be equal to what, guys? What we can write? Fr is equal to 1/7 of the mg. Or we can write mg by 7. Okay, any doubt in this discussion, guys? Try to see the scenario here. Try to observe the things here. Okay, now my question for all of you. So we have thrown the object vertically upward. How the object is going? Object is going, throwing the object vertically upward. Now, how many forces acting on this object, guys? Try to see the scenario here. How many forces? Suppose this is what our object. Okay, try to see the point here. So this is what our object. We don't know its mass. We assume its mass as a m. This is what our object. Okay. See how we have thrown the object vertically upward. So motion of the object is what? How is the motion? How is the motion? Motion is what, guys? Motion is upward. Okay. Now, what are the forces acting on this object? On this projectile? On this projectile, first of all, guys, its weight, that is meant by its gravitational force, mg. Okay, mg, we can show mg like this also. This is also possible scenario, guys. We can show mg like this also. Okay, or we can show mg like this also. Okay, guys, are you getting my point? Try to see the scenario here. Okay. So here everyone try to see the point here. So the next point is here what? So this is what our projectile. This is what our projectile. Okay. Now, so we have shown in two ways we can show the weight. One is up to like this. One way is what, guys? Like this. Okay. Or another way is what? Like this. Okay. Both are the valid way. Okay. Okay. So this is what our projectile. Now motion is upward and we know resistance is always opposite to the motion. Resistance is what, guys? Always opposite to the motion. So here what? So opposite to the motion will be what? So this will be what, guys? Our Fr. Fr stand for air resistance force. Okay, guys, are you getting my point? Try to see the scenario here. Okay. Any doubt in this discussion, guys? Now my question for all of you. Guys, listen my words carefully. My question for all of you. Can we apply equation of motion in gravitational field here? Can we apply, guys? I'm mentioning once again. I'm saying once again question. Can we apply equation of motion in gravitational field here? Can we apply equation of motion in gravitational field here? No. Why we can't no apply? Why? No. Yes, here, guys, not just gravitational force, mg is not only acting here. Here with mg, what is another force? Air resistance force is also there. Guys, are you getting my point? Try to see the scenario here. The questions we previously discussed, last two questions we previously discussed. In that two questions, what was the scenario, guys? Though we have thrown the object there, only gravitational force is acting, and in that scenario we assumed air resistance is negligible. Here they are assumed. But here air resistance is not negligible because they have clearly mentioned in the question. If they have not mentioned in the question, then by default it is a negligible air resistance. Okay, guys, any doubt in this discussion? Okay, good. Good. So now here we can, guys, what we can say? Here we can't apply equation of motion in gravitational field. Okay, what I am saying? Here we can't apply equation of motion in gravitational field. We can't apply. Okay, equation of motion in gravitational field. Normal equation of motion we can apply, but equation of motion in gravitational field we can't apply. Okay, so here we can say directly, we will say we are going to use normal equation of motion, regular one. Okay, that previous one we studied. Only equation of motion we can apply, not equation of motion in gravitational field. Okay, now what they are asking us in the A part, guys. Now try to see that scenario. In A part, what they are asking us? Time taken to reach the maximum height. Okay, so in A part, what is our target? In A part, what we have to find out, guys? Maximum, what guys? Maximum height. Okay, good, very good. That is the B part, okay. So, time to reach the maximum height. Okay, what they are asking us? To reach, guys, see the scenario. Okay, very good. Time to reach the, guys, always be attentive. Okay, time to reach the maximum height. I may do such type of mistake, so you have to be careful. Okay, so in B part, what they are asking us? What they are asking us? Time to reach the time taken to reach the maximum height. So, to reach the maximum height. So, at maximum height, what is the speciality of maximum height, guys? What is the speciality? Up to what point this projectile will go? Means projectile starts from with a velocity of 305 meter per second. When it goes up, what will happen? Its velocity will get reduced. Okay, its velocity starts reducing. Okay, at every second. Now, guys, my question for all of you: up to what point it will go? Up to what height it will go, guys? What is the speciality of that topmost point? Yes, at maximum height. What we can say? At maximum height. What we can say, guys? At maximum height, velocity will become what? 0 meter per second. Guys, try to see the scenario. At maximum height, velocity will be equal to what? 0 meter per second. Try to see the scenario. Very important discussion. Okay. So, guys, I'm writing it. I want to save some space. Okay. So our target is what? We have to find out. In A part, we have to find out time. Time for what? To reach what? Maximum what? Maximum height. Okay. And at maximum height, what we can say? At maximum height, what we can say? Velocity will be equal to what, guys? 0. Any doubt in this discussion, guys? Okay, good. Now, see the scenario. We are nearer to our answer. By Newton's second law of motion. By Newton's second law of motion. Okay. What is Newton's second law of motion, guys? Can anyone tell me? By Newton's second law of motion. What is Newton's second law of motion? Can anyone tell me? By Newton's second law of motion. What is Newton's second law of motion, guys? Summation of force is equal to ma. And here motion is only in one direction. Motion is only in one direction, and in the same direction forces are acting. Okay, either upward or downward. Okay. So forces in the direction of motion can be considered as positive, opposite forces negative. Now what are the forces here in the direction of motion? Which forces are here in direction of motion on this projectile, guys? Which forces are here in the direction of motion? No force is there. Okay, good, very good. And but the opposite is what? Minus Fr and minus mg is equal to ma. Try to see the scenario, guys. Very important discussion. Now what is meant by Fr? Minus mg by 7 minus mg is equal to ma. What is common in each and every term? What is common here each and every term? What is common in m is common, so we can cancel this m. Guys, can we cancel this m? Because it is common in each and every term. So we can cancel this m. So what will become this one, guys? So acceleration will become what, guys? Minus g by 7 means what? 9.81, guys. Minus 9.81 divided by 7 minus 9.81. So what will be the acceleration, guys? Everyone, please do this acceleration. Everyone, are you getting my point? Try to see the scenario here. How much guys? How much acceleration we are getting? How much acceleration? Can anyone tell me? Wrong. No, not minus 8.1. See here we have a minus plus minus 11.2114 unit meter per second square. And what is the relation for acceleration guys? Acceleration is equal to what we can write? V minus u by t. Okay, acceleration is equal to v minus u by t. And see guys, don't worry, if you are getting acceleration negative, it means what? What is the meaning of, if you are getting acceleration negative, what is the meaning of this one guys? What is the meaning of this one if you are getting acceleration negative? What is the meaning of this one? Why we are getting acceleration negative guys? Can anyone tell me? Why we are getting acceleration here negative? Yes, because here deacceleration, here velocity is reducing. Initial velocity is what? 305 meter per second and final velocity is what? 0 meter per second. So in every second our velocity is reduced by what? 11.2114 meter per second. Okay, that is the meaning of acceleration. Now guys, what is meant by acceleration? Acceleration means what? Change in velocity in every second. Okay, in per second how much velocity is changed, and here per second how much velocity is changing? 11.2144. It is reducing. That's why here it is a minus. Okay, so what we can say? Time is equal to what guys? Time is equal to what? V minus u by a. What is the value of v? Final velocity is what? 0. Minus u is how much guys? 305. Very simple question guys, not that much difficult. Minus 305 divided by what guys? What divided by? Minus 11.2114. Okay, so what will be the time guys? Can anyone tell me time? So 305 divided by 11.2114. How much everyone? 27.2044 unit second. Okay, in this much time projectile will reach to the maximum height. Okay guys, are you getting my point? Anyone have any doubt in this discussion? Okay, so first of all guys, write down these things. After that, give the heading, then draw this drawing. Beside this drawing, please write down this up to time. Okay, please everyone complete this point. Now guys, what they are asking us in the B part? The maximum height attained by the projectile. Okay, so what is our target in B part? What we have to find out in B part? In B part we have to find out maximum height attained by the projectile. That is what our target. Okay, so what is our target here in B part? We have to find out maximum height attained by the projectile. Okay, try to see the scenario. In B part our target is what? Maximum height. Okay, good. So try to see the scenario. Very simple discussion guys. So we know our equation of motion, v square is equal to u square plus 2g, plus 2as. Okay. Okay guys, now our regular equation of motion, not equation of motion in gravitational field is not applicable here. So try to see the scenario. So here s will be equal to what? V square minus u square upon what? 2a. What is the velocity? Final velocity 0. Initial velocity 0 square 305 square divided by what? 2 into acceleration is how much guys? How much we calculated acceleration? Minus 11.2114. Okay, so please everyone do the calculation, and whatever the displacement the projectile will follow, that displacement will be what? Our maximum height. Okay guys, are you getting my point? Try to see the scenario here. Okay, please everyone do the calculation. Okay, what is the value we are getting guys? Can anyone tell me? How much value we are getting guys? 41 48.68 unit meter. So this is what? So therefore maximum height will be what? What will be the maximum height, guys? 4148.68 meter. Okay, so this is what our B part answer. Okay, very simple story, guys. Only understanding the question is difficult, otherwise this question is very, very simple. Okay, please everyone complete this B part. Now guys, try to read the C part, what they are asking us in the C part. Okay, try to see the C part here. The time, try to see the C part. The time the projectile takes to fall from a maximum height to its starting position. Okay, now how is the motion of the projectile in C part, guys? Okay, so try to see the C part. C part is again quite interesting. In C part, how is the motion? Now what they are asking us in C part, time taken for the projectile to fall from a maximum height to its starting position. Guys, see, in A part what they ask us in the A part, guys, in A part they ask us time taken by the projectile to from its starting position to reach the maximum height. But here in C part what they are asking us, time taken for the projectile from maximum height to reach the starting point. Okay guys, see the scenario. Now my question for all of you, is it the same or different? Time, see, my question is, try to understand the question. Suppose this is what our starting point. Okay, starting point of the projectile. Projectile will reach to the maximum height. This is the maximum height. Okay, it will require some time. Okay, we calculated that time 27.2044. Okay, once projectile reach to the maximum height, then it again falls back. Okay, now my question for all of you guys, is this time same or different? Is this time means from here to here, means suppose this is what our starting point, maximum point. Okay, this is maximum height, and again coming back. Okay, means from, okay, I will say 1 to 2 and 2 to 3. So time for 1 to 2 and 2 to 3, is it same or different, guys? Time for 1 to 2 and 2 to 3, is it the same or different? Means from starting point to maximum height and from maximum height to again starting point, is it the same or different, guys? Why different? Yes, okay guys, see in this scenario, in this 2 to 3 scenario, when it is falling down, okay, if you try to observe the scenario here, just try to observe the things. This is what our projectile, guys, whose mass is m. Now in this scenario, as the motion is what, guys, how is the motion in this scenario? Motion is what, guys? Downward. Okay, motion is downward, so acceleration is along the motion. So how is the resistance force, guys, here? In this scenario, resistance force will be what? Opposite to the motion. But here resistance force is, see, resistance force is what? Opposite to the motion, means upward. But in this scenario, motion is upward, so resistance force is what, guys? Downward. Okay, try to see this, both the drawing, this drawing and this drawing. Here motion upward, resistance force downward. Here motion downward, resistance force upward. So that's why here direction of resistance force is changing. So what will happen, guys? As the direction of resistance force will change, what will happen, everyone? Okay, so that's why time required from 1 to 2, means starting point to maximum height, and from maximum height to again starting point, is it different? Okay guys, are you getting my point? Try to see the scenario here. So now try to see the scenario. Next point. So weight will be here. So weight will be what, guys? I told you, means we can show weight like this also. We can show weight like this also. Okay, according to situation, whatever the thing we feel comfortable. In this drawing we feel mg, we can draw like this. It is feeling comfortable to us to draw like this, and it is simple also drawing like this. Diagram will become simple, and here we have shown mg like this because we want a drawing simple, we don't want any complications. So this is one of way of showing mg. This is another way of showing mg. And what is meant by mg? Mg means weight. What is the meaning of weight? Weight means gravitational force. Okay, so guys, try to see the scenario here. So what is our target in C part? We have to find out time. Time for what, guys? What is exactly wording? What is the exact wording of the question? Okay, I am read the time the projectile takes from maximum height to starting position. Okay, so from maximum height. Okay, for what purpose they are asking us time? From what, guys? From maximum height to what? To what? Starting position. Okay, everyone try to see the scenario. Very simple discussion. Okay, guys, try to observe the point. So when projectile it at maximum height, it's so our motion is what? From top point to the bottom point. Okay, so initial velocity in this scenario will be what? 0 meter per second. Guys, when projectile is going from, this is what, guys? So projectile is falling from this level. Okay, try to see the point here from maximum height. Okay, this is what a maximum height, huh? Everyone. This is what our, okay, 1 minute. I'm going to draw proper drawing so that it is properly visible to us. So this is what our starting level. Okay. So this is what our starting level. This is what our, this is what, guys? Our maximum height. Okay, try to see the scenario. And projectile is what? What is projectile is doing? Projectile is coming down. Okay, so what will be the initial velocity in this motion? What will be the initial velocity, guys? Here 0 meter per second. What will be the displacement in this scenario? What will be the displacement, guys, in this scenario? Yes, will be what? See, what is this distance, guys? What is this distance? What is this distance, guys? What is the distance? How much? Here we will not say why, because here this is not a equation, motion in gravitational field. Huh? Though it is motion in gravitational field, but alone it is not only gravitational force acting. Here we will use, okay, what is the distance we calculated here? Guys, we calculate this distance in B part. Can anyone tell me? 4148.68 unit meter. Okay, so displacement will be what, guys? How much projectile has to travel distance? Okay, 4148.68. and in this scenario, don't worry about sign convention. Sign convention is important in case of what, guys? Equation of motion in gravitational field. But here we are not applying equation of motion in gravitational field. And why we are not applying equation of motion in gravitational field? Because along with gravitational force, another force which acting here, resistance force is here also we are acting on this projectile. So we can't apply equation of motion in gravitational field. Okay, everyone getting my point? Try to see the scenario. Very simple discussion, nothing too much difficult. Okay, so try to observe the things here. So what is our target? We have to find out time. From what point? From maximum height to starting position. And here we have to, first of all, what we are going to do? Try to see the scenario. Very simple discussion. Now, how to find out time, guys? How to find out time? How to find out time, guys? First of all, we will use what, guys? By Newton's second law of motion. What we are going to do? What is our Newton's second law of motion? Can anyone tell me? By Newton's second law of motion. By using Newton's second law of motion, what we can do? By using Newton's force is mass into acceleration. Okay, by Newton's second law of motion, summation of force is equal to what, guys? Mass into acceleration. Okay, forces in the direction of motion considered as positive, opposite forces negative. Here, which force is in the direction of motion here? Which force here is in the direction of motion? Only mg, so we consider mg as a positive. Which force is in the opposite to the motion? Which force is here opposite to the motion? Fr is opposite. So here we can say minus Fr is equal to what, guys? We can say Ma. So mg is equal to what? Fr means what? Mg by 7 is equal to what, guys? Ma. So we can cancel what we can do, guys? We can cancel this m because it is in every term. So acceleration will become what, guys? G means what? 9.81 minus 9.81 divided by what, guys? 7. So in this way we will get acceleration. Everyone, please do the calculation and tell me the value of acceleration. So 9.81 minus 9.81 divided by 7. What is the value, guys? 8.4086 unit meter per second square. Okay, so in this way what we got, guys? We got the acceleration. Everyone, try to see the scenario. Very simple discussion and important one also. Okay. So after acceleration, we can apply equation of motion. Okay, regular, not equation of motion in gravitational field. We can't apply equation of motion in gravitational field in this scenario. And why we can't apply equation of motion in gravitational field? Because along with gravitational force, air resistance force is also acting here. Okay, now try to see the scenario here. So we know second equation of motion, S is equal to what? Ut minus what? Half gt square. Okay, S value is how much? Yes, guys, what is the value of S? 4148. Okay, 0.68. Initial velocity is how much, guys? Initial velocity 0. Okay, so this term will become 0. Okay, I have written wrong, guys. Ut plus half at square, not equation of motion in gravitational field. So 0 plus half. Acceleration here is what? 8.4086, and we have to find out time. So guys, see here acceleration we are getting positive. Why we are getting positive? Because when object is moving downward, its velocity will increase. Try to see the point here. So time will be equal to what, guys? Under root of 2 times 4148.68 divided by what? 8.4086. Everyone, please do the calculation and tell me the value of time. Okay, everyone, please do the calculation and tell me the value of time. 2 into 4148.68 divided by what? 8.4086. How much, guys, we are getting? How much time we are getting, guys? 31.413 unit second. Okay, guys, are you getting my point? Any doubt in this discussion? Try to see the scenario. Very simple discussion. So please, everyone, first of all, write down the target of C part, then draw this drawing. Beside drawing, draw also this drawing, because this drawing will give you an idea how the story is going on here. Okay, then initial velocity, displacement, then Newton's second law of motion, and then our equation of motion. From equation of motion, what we got? We got the time. Okay, please everyone, write down all these points. Okay, everyone.